Hello, welcome back to Scholar Strive doing some math. Today we'll be solving rational equations. Before we were simplifying, adding, subtracting, multiplying, dividing rational expressions, and it all leads up to this. So, in the good old days when we had a fraction equal a fraction, we did cross multiplication. So we took our numbers here, a times d, and then multiplied and set it equal to b times c. We're just going to do the same thing. We have a fraction equal a fraction, so we're just going to multiply the two. So 3 times 4x plus 5 equals 9 times x plus 1. Distribute. So I have 12x plus 15 equals 9x plus 9. I'm going to subtract 9x over from both sides, and I'm going to subtract 15 from both sides. So I'll get 3x on this side, and I'll get negative 6 on this side, so x equals negative 2. So we're going to show a complete check by plugging it back into our original equation. So I have 3 over negative 2 plus 1 equals 9 over 4 times negative 2 plus 5. So I'll get 3 over negative 1 equals 9 over negative 8 plus 5. So I have negative 3 over 9 over negative 3. So negative 3 does indeed equal negative 3. Alright, number 2. Same thing, cross multiply. Negative 6. 6x plus, or x minus 1 equals negative 12 times x plus 2. So I'll have negative 6x minus 6 equals negative 12x minus 24. Oh, that's a plus 6 there. So I'm going to add 12x to both sides and then subtract 6 from both sides. So I'll get 6x equals negative 30. X equals negative 5. So plug it back in. I'll have negative 6 over negative 5 plus 2 equals negative 12 over negative 5 minus 1. So I'll have negative 6 over negative 3 and negative 12 over negative 6. That'll equal 2 equals 2. Yep, that works. Alright, let's make it a little bit harder. So the reason why we found the else, and we're working with adding, subtracting fractions, we found an easier way, but this only works if you have the equal sign, is by multiplying the entire top by the LCM. This will get rid of our denominators, and we'll have an easier problem. So first we're going to find the LCM of our 3 denominators. So we have x, we have 4, and we have x. So they have an x here, and we have a 4. So because we don't use x squared is because the first fraction and the third fraction already share an x. So we'll use it once. And then we tack on whatever's left, the 4. So my LCM is 4. So what's happening here is I'm going to multiply the entire top by 4x over 1. So I'm going to have 5 times 4x over x plus 7 times 4x over 4 equals negative 9 times 4x over x. So this 4 gets canceled out here, this x cancels out, and that x cancels out. So I'm left with 5 times 4, which is 20, plus 7x equals negative 30, or positive 30, or negative 36, yeah. Negative 9 times 4x. So that's a negative 36. Subtract 20 over, and I'll get negative 56, so x equals negative 8. If you plug this back into the equation, it'll work. Number 4. So remember when we have a whole number, you just put it over 1. So now we're going to find the LCM, which happens to be x times x minus 5. So we're going to multiply the entire top by x times x minus 5. So I have 1 times x minus 5 minus 8. Let's go ahead and put some minus 8 times x minus 5 equals 3 times x minus 5. And then let's put their denominators. That was 1. That was x minus 5. And that was x. Cancel out what we can. So I'm left with x squared minus 5x minus 8x, because the x minus 5s are gone. And then this is 3 times x, 3 times negative 5, so equals 3x minus 15. So this is looking like it's going to be a quadratic equation, so I'm going to move everything to the left side. So I'm going to add 15 and subtract 3x. Actually, let's simplify this a little bit. X squared minus 13x equals 3x minus 15. Now I'm going to move those over by subtracting 3x and adding 15. So I'll get x squared minus 16x minus 15, or plus 15, equals 0. So this will factor into x minus 15 and x minus 1. So either x equals 15, or x equals 1. And then make sure you plug these back in, and in this case, they both work. Alright, let's move on to number 5. Okay, LCM. So remember, when you're looking for the LCM, make sure to factor everything that you can. So for example, this x squared minus 9 is actually x plus 3, x minus 3. So my so my LCM is actually x plus 3, x minus 3. Because the first fraction is missing x plus 3, The second fraction is not missing anything. And the third fraction is missing x minus 3. Okay, so I'm going to multiply the entire top by my LCM. So I will have 6 times x plus 3, x minus 3 over x minus 3 equals 8x squared times x minus 3, x plus 3 over, we figured this out to be x minus 3, x plus 3 minus 4x over, or times x plus 3, x minus 3 over x plus 3. Cancel out, so those go away, and these go away. So I'll have 6x plus 18 equals 8x squared minus 4x squared plus 12x. This looks quadratic-like. So I'm going to get 6x plus 18 equals 4x squared plus 12x. Move things over. I'll get 0 equals 4x squared plus 6x minus 18. I'm going to factor out 2. So I'll get 2x squared plus 3x minus 9. And this will factor into 2x minus 3, x plus 3. Because 2 times 3 is 6, minus 3 is 3. Yep. Now what line are you doing here for? Alright. So, set this equal to 0. 2x minus 3 equals 0. And we don't have to worry about this 2 because there's no x there. So 2x equals 3. So x equals 3 halves, or 1.5. And then for here, we have x equals negative 3. In this case, when you run through your whole check, this x equals negative 3 does not work when you plug it back in. And the reason behind that is you get undefined in one of the denominators. So, this is your only answer, 3.5. Okay. All right, number 6. So remember, whole numbers, just put it over 1. Let's clean this up a little bit. There we go. LCM is, oh, that one's easy. Just x minus 2. So I multiply the entire top by x minus 2. So I have 5x, x minus 2 over x minus 2 equals 7 times x minus 2 over 1 plus 10 x minus 2 x minus 2. Cancel out what we got. So I have 5x equals 7x minus 14 plus 10x. Oh, sorry, those canceled out, just 10. So I have 5x equals 7x minus 4. So I have negative 2x equals negative 4. So x equals positive 2. And then I put this into our check. And when I'm plugging it back in, I notice that the denominator, if I put in the denominator 2 minus 2, that equals 0. That makes it undefined. So this does not work. So no solution. Undefined. Alright, move on to the next page. Alright, word problems. An alloy is formed by mixing two or more metals together. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. Jewelry silver is composed of 80% silver and 20% copper by weight. How much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? Okay. So, we want to know the percentage of let me pause this really quick. Alright, here we go. So we got percentage of copper for the sterling silver. Equals the weight in copper over the total weight. Total weight. And we know that the percentage of copper for sterling silver is 7.5 out of the 100. And we're going to set that equal to the weight in copper, which we know to be 20%. 0.2 times 15. Because 15 is our total weight. Over the total weight, which is 15 ounces of the jewelry silver plus our pure silver. So once again, that's our pure silver. So just to back up, we know that sterling silver is made up of 92.5% silver and 7.5% copper. So since we know that, that's why I put percentage of copper for sterling silver, 7.5 over 100, equals the amount of copper we use, which is 20% of the 15, divided by the total weight, 15 plus W, where W is the pure silver. So, do some cross multiplication, and I'll get 112.5 plus 7.5 W is equal to 100 times 0.2 times 15. So 112.5 plus 7.5 W equals 300. So 7.5 W equals 187.5 W. The amount of pure silver needed is 25 ounces. Okay. The cost of fueling your car for 1 year can be calculated using this equation. Okay, fuel cost for 1 year equals miles driven times the price per gallon divided by the fuel efficiency rate. Okay, so last year you drove 12,500 miles, paid $2.15 per gallon of gas, and spent a total of $1,225.50 on gasoline. What is the fuel efficiency rate for your car? So this is the cost for a year, or the year cost. This is the price per gallon, and then miles driven. So that's one. This is an easy formula. You just put everything in. 12,500, or whoops, 1225.50 equals 12,500 times 2.15 over X, or R, whatever, I'm just going to call it X. So we have 25.50 equals 26,875 over X. So that means X is going to equal 26,875 divided by 1225.5. So X equals 21.9 miles per gallon. So how much would you have saved if your car's fuel efficiency rate was 32 miles per gallon? So we went to 12,500 times 2.15, $2.15 per gallon, which is actually quick English, divided by 32, and that would have gave us $839.84. So to see how much we would have saved if we had a more fuel efficient car, take the 1225.5 originally, and subtract 839.84, and that would have given you $385.66 in savings. Alright, hopefully that helps. Have a good day.